Okay, thank you very much for your so kind introduction. This is my disclosure of interest. Okay, I just received several funds from Italian Ministry of Health and received several honorarium for speaker from a couple of societies, Tallergens and Thermo Fisher. Okay, first of all, I'd like to give you some hints regarding algorithms. What does it mean? In mathematics and computer science, an algorithm is considered as an ambiguous specification on how to solve a class of problem. And this definition obviously cannot be used for biological systems. In medicine, medical algorithms include decision tree approaches to healthcare treatments. Therefore, you can use a given treatment in the presence of given symptoms. And in allergology, the diagnostic algorithms in the so-called inductive diagnostic approach are mainly based on a first-line approach, which is represented mainly by clinical history, which is the most important part of the story, that is followed in the vast majority of cases by a second-line approach, which is represented by allergen extract-based testing. And the problems, unfortunately, can start at this point, because when you use an allergen extract-based testing, first of all, you have no idea of what can give you reactivity or not reactivity to that given extracts, because what we deserve from an allergen, from an extract to be used for the clinical practice, is the fact that all the relevant molecules possibly responsible for Ig sensitization in your patient should be all equally represented in your final product. But since not all molecules are equal, and therefore several molecules could be more labile than others, several molecules could be underrepresented in your final product or even absent, being the possible cause for a false negative result. And it might also happen that several contaminants could be represented in your reagent, being the possible cause for a false positive result. But all such information, all such consideration have been widely published in the last 20 years. For example, demonstrating the total absence of several important molecules, for example, in this case, choreate from hazelnut in several reagents, so the possible presence or absence on the basis of what batch is considered for overall an extreme heterogeneity in content of molecules when you consider different distinct manufacturers or the same manufacturers considering a different batch. In this paper of more than 20 years ago, it has been demonstrated that how does mite molecules could be found within animal dander, in this case dog dander extracts. In this more recent paper, it has been demonstrated that extreme heterogeneity in both major and minor molecules within house dust mite extracts, and the same has been already demonstrated for grass pollen. And taking together such considerations, several opinion leaders in the past proposed to revert the order for diagnostic algorithms in allergology in a sort of deductive approach where you have, first of all, to verify the Ig sensitization profile versus molecules, and only thereafter explain to the patient his or her possible Ig sensitization profile. But such approach is at least unrealistic at the moment, because there are no more than 130 molecules available in the market out of precisely 906 molecules currently described and registered in the IUIS database, and possibly out of 9 million molecules possibly found in the environment, as demonstrated in this paper, where up to 42 previously undescribed allergen has been identified, able to induce IL-5 synthesis by T-cell lines from allergic people and to induce both IgG and IgE synthesis. At a continuous comparison among already known extracts and already known molecules led the group of Pascal Poncet to identify an interesting new allergen family possibly involved in pollen food-associated syndrome, the snaking gibberellin-regulated proteins, because such molecules, the BP14 from Cupressus sempervirus is allergenic and is cross-reactive with other members of the same family already demonstrated and published recently from Italy and Japan and found within pomegranate, peach, sweet orange and Japanese apricot. Therefore, a continuous mixture from classical and more modern approach seems to be the best way to face the allergy diagnosis nowadays, combining both possible approach, since molecular-based allergy diagnosis is nowadays considered as a third-line approach to be used when the first two lines are inconclusive. But such approach could be also used as a second-line approach for experienced user, in particular case when the clinical history clearly deserves such kind of approach. In our institute, since 2006, a multiplex system has been used for the detection of IgE sensitization, and we could evaluate to date more or less 70,000 people with such an approach. An immediate added value that you can gain evaluating at the same time currently more than 100 molecules in the same patient is the fact that you can immediately have the perception that the demonstration of presence of a species-specific versus cross-reactive sensitization. The first being extremely important to define a genuine sensitization versus a given allergenic source, which is the most important thing to do to prescribe accurately an allergen immunotherapy. And the second one, important for define the possible recognition at the same time of different biological sources, even not related, but above all to predict possibly the outcome of your patient, because on the basis of what kind of molecule is possibly responsible for multiple sensitization, you can predict the presence or not of a severe adverse reaction. And at this point, to fulfill my task, I choose to present two distinct models of sensitization involving inhalant allergy or food allergy. And starting with the first model, the model chosen was the tree pollen allergy, which represented the third most common cause of IgE sensitization in Western country, mainly driven by plants belonging to the order of Phagales, Lamiales, Spinales, and Proteales. And the first algorithm is the simplest. When you have a monosensitization to a given extract and a demonstration of the genuine recognition of the proper molecule, you can prescribe an allergen immunotherapy without any problem. And this is true for Coupe1 from cypress pollen, Betwe1 for birch, Olive1 for olive tree, and Playa 1 and 2 from plant tree. Problems could arise in the presence of polyreactivity, because polyreactivity to all the extracts considered, cypress, olive, birch, and plant tree, could be the result of genuine sensitization, genuine recognition of the proper molecules belonging to the respective biological sources. But the same polyreactivity from an extract's point of view can be the result of only one genuine sensitization in the presence of panallergen sensitization, in this case profilin or polcalcin. And on the opposite way, you can have no genuine sensitization, just polyreactivity due to profilin or polcalcin recognition. And obviously in this case, you have to check for other genuine sensitization, you have to perform no allergen immunotherapy. And I'd like to show you two interesting models of sensitization, further models. The first represented by reactivity at the same time to cypress and plant tree. Because in this case, if the reactivity is due to Coupe1 and Playa 2, since both molecules are native molecules, you have to rule out, to exclude the possibility that such reactivity could be the signature of a cross-reactive carbohydrate determinants recognition. In fact, in the presence at the same time of UGAR2 from walnut, the two molecules from grasses, Cindy1 from Bermuda grass and Friumpi4 from Timothy grass, in the absence of Friumpi1, which is a recombinant molecules, you have to suspect the presence of CCD reactivity and rule out such evidence by means of a simple inhibition test that can let you to totally absorb the signals due to CCD recognition and just disclose the only one genuine sensitization, in this case PARG2 from pellitory of the wall. And one important thing, the presence of CCD reactivity does not exclude a possible genuine recognition of the same molecule. Therefore, with an inhibition test, you can exclude such further possibility. Another interesting model is represented by the presence at the same time to reactivity of versus olive tree and plant tree, because such multiple recognition can be the result of genuine sensitization, olive 1 from olive tree and plant 1, 2 from plant tree, but at the same time can be the result of recognition of two molecules, olive 7 and plant 3, that are, in the case of plant 3, we and other groups could demonstrate that plant 3 is a lipid transfer protein. In fact, is associated with both local and systemic reaction to food and not with respiratory symptoms, as well as in the case of OLA7, that affect more or less 20% of patients with olive tree reactivity in our country, in central and southern Italy. But such molecule seems to behave exactly like the other lipid transfer protein. In fact, is associated with oral allergy syndrome and systemic reaction to food and not with respiratory symptoms, thus behaving in an opposite way if compared to OLA1, which is the genuine molecule for olive tree reactivity. And the reason why OLA7, which is considered a putative lipid transfer protein, not a true lipid transfer protein, seems to behave exactly like the other lipid transfer protein, can be explained observing the amino acid sequences of lipid transfer protein. In this slide, I just put the amino acid sequences and compare the amino acid sequences of the 7 lipid transfer proteins currently found on the microarray. And as you can see, we can find no more than 80% of sequence identity, which is a pretty low level if you consider that such molecules are co-recognized. But the reason for such apparent discrepancy is the fact that it's known that there are 3 main Ig binding epitopes distributed along the surface of lipid transfer protein, named after their location on PP3 as PP3 1120, 3140, and 7180. And when we compare the small fragment of OLA7, which is currently registered in the UIS database, to the other structure of the other lipid transfer protein, here are such fragments allocate exactly in the correspondence of the first Ig binding epitope. Therefore, we can hypothesize that those patients we see in our country affected by OLA7 reactivity are patients that are able to detect the first Ig binding epitopes, therefore are lipid transfer protein allergic patients. And if you merge such information with the well-known role of R2-3 as a lipid transfer protein from mugwort, please consider in the case of multiple sensitization at the same time to mugwort, plant tree, and olive tree, the possibility that such 3 sensitization could be the result of R2-3, PLY3, and OLA7 sensitization, therefore disclosing a lipid transfer protein reactivity. This is a quite cute way to demonstrate how you can perform a food allergy diagnosis while you are searching for inhalant allergy. And there are several examples for that. For example, the presence at the same time of birch, alder, and hazel reactivity can disclose a PR10 reactivity. The presence of house dust mite and cockroach can disclose a possible reactivity to tropomyosin, and so on and so far. As such an example, let me the chance to move to the second and final part of my talk, food allergy, where I'm going to cover mainly panallergen reactivity. We know that on the basis of what kind of panallergen is involved in the reactivity of your patient, you can have a worsening of symptoms. And in the case of CCD, we could demonstrate in the past that CCD reactivity is totally clinical irrelevant in the world of vegetable CCDs. In fact, we could feed 7 patients having very high levels of IgE2 CCDs with up to 1 gram of lactoferrin cultivated in rice, therefore plenty of CCD without any problem, therefore demonstrating that CCDs are unable to induce mastocyte degranulation in our patients and are clinically irrelevant in the world of vegetable CCDs. And when we used a program founded found on the internet, able to generate word cloud and just put the frequency, the prevalence of molecular recognition in different clinical pictures. This is what happened in the case of oral allergy syndrome. As you can see, the vast majority of molecules involved in such condition, such clinical condition, are molecules belonging to profilin and PR10 panallergen families. Profilin are considered a sort of archetypal panallergen because molecules belonging to profilin are really similar, really homogeneous, as demonstrated by the slide where you can see a lot of dark gray bands indicating identical position and light gray bands indicating similar position for overall 68% of sequence identity. In this slide, I just compared the 4 profilin currently found on the Eaaci system, profilin belonging to latex, Timothy grass, birch, and annual mercury. And such structural characteristics, such identity, is reflected in the immunological behavior of such molecules that were co-recognized in the vast majority of cases. In fact, when we evaluated 566 patients, as you can see, we could observe the presence of very high levels, high values of person correlation coefficient. We know that person correlation coefficient is considered indicating a strong relationship when the level is above 0.7. As you can see in this case, in all cases, we could find the presence of very high level of person correlation coefficient, but despite such observation, none of the profilin considered was able to detect all 566 patients studied. And this is an important point. When you are considering a multiplex system, the more molecule you test, the better it is, because the system is not so sensitive, because you are just evaluating one single isoform from each single molecule. Therefore, when you test more molecules, you can be more confident in detecting all possible patients affected by a given panallergen sensitization. And if this is true for profilin that show 68% of sequence identity, the same observation can be made in the case of PR10 reactivity, where the sequence identity is even lower, 27%, as you can see. We know that the Ig binding epitope are equally distributed along the entire length of PR10 molecules. And the Ig recognition profile is highly patient-specific. Therefore, there is an heterogeneity in recognition of different PR10 molecules. As such, heterogeneity is reflected also in our data, where, for example, we could observe the presence of a significant person correlation coefficient only sometimes, mainly comparing or observing the co-recognition of molecules belonging to related, but botanically related molecules, as is the case of apple and peach PR10, of the 3 PR10 belonging to Betulaceae, BetW1, Cori1, and Algae1. But in all the other cases, when we compared peanut, celery, soybean, so on and so far, no significant relationship could be achieved. And when we also verify the molecular recognition combination of the 10 molecules, the 10 PR10 molecules considered, we could observe precisely up to 100 distinct combinations. Therefore, groups of patients recognizing 4 molecules, 3 molecules, 1 molecule, and so on and so far. In the slide, I reported the first 15 more frequent molecules recognition combination, encompassing more or less 60% of patients, as a further demonstration of the heterogeneity of recognition of such molecules. And such heterogeneity should have, and in fact has, a clinical impact, a clinical significance. In fact, when we use a multiple correspondence analysis to verify our data, with such approach, every single molecule is resumed as a point in the space, so you can immediately observe relationship among molecules. And for example, the 3 molecules belonging to trees are placed in the lower part of the motion, are strictly related one to each other, and are mainly associated with respiratory symptoms, whilst a divergent behavior could be observed for the PR10 molecules belonging to plant food that are placed on the upper part of the figure and are mainly associated with oral allergy syndrome. And moving on to severe reaction, once again, when we put the frequency of reactivity, molecular reactivity in this specific subset of patients, we could observe the presence of mainly lipid transfer protein reactivity and seed storage protein reactivity. You have already seen such slide demonstrating the presence of the 3 IgE binding epitope, and in this case, as already shown for PR10 molecules, we also observed an heterogeneity in co-recognition of such molecules with slightly higher levels of person correlation coefficients, but once again, an heterogeneity in recognition of molecules. And once again, such heterogeneity is reflected in the different behavior from a clinical point of view of our patients. In fact, we could observe that the subset of patients able to recognize more than 5 molecules had a 4.6 higher risk to develop systemic reaction to food if compared to the other population. And recently, really recently, we could perform a multicentric study along Italy involving several centers, and we could observe, studying 6,500 patients, several interesting pictures of sensitization different in different parts of Italy, demonstrating the possible importance of geographical exposure in the IgE sensitization. And we could also demonstrate and confirm the fact that when you are reacted to a given panallergen, in the vast majority of cases, you do not recognize the other panallergen. Therefore, the panallergen recognition is mutually exclusive in at least 70% of cases. But there are 30% of patients that could be allergic at the same time to more than one panallergen. And several years ago, the group of Elide Pastorello demonstrated that peach allergic people are reactive at the same time to PRP1, 3, and 4, therefore to PR10, lipid transfer protein, and profilin, had a significant lower risk to develop systemic reaction to food. And when we evaluated such data also in our patients, if these are the prevalence of local reaction, systemic reaction in pure lipid transfer protein reactors, patients having just reactivity to lipid transfer protein and no reactivity to other panallergen. This is what happened in the case of PR10, profilin, or both reactivities. As you can see, we could observe a significant higher risk to develop local reaction, whilst on the other hand, a significant lower risk to develop systemic reaction to food. Therefore, these are a couple of important clues for clinicians: the presence of less than 4 lipid transfer proteins, the possibility to recognize more than one panallergen could be considered as a factor associated with lower risk to develop systemic reaction to food, but cofactors as a role. In fact, it's already well known that the presence of different several cofactors could enhance food allergy. And we could demonstrate in the past that food-dependent exercise-induced anaphylaxis is associated, mainly associated in the Mediterranean area with lipid transfer protein reactivity. Other groups demonstrated that ingestion of non-steroidal anti-inflammatory drugs could enhance severe reaction to lipid transfer protein, but I'm not so sure that the girl is taking an aspirin. Okay, and finally, the ingestion of alcohol could also augment the risk to develop a systemic reaction to lipid transfer protein. Therefore, in order to summarize my talk, we have seen the diagnostic algorithm in an allergy with the simplest situation, monoreactivity, where you can just choose the proper allergen immunotherapy without any problem, polyreactivity that you have to disclose with molecular approach in order to distinguish the presence of genuine sensitization versus panallergen reactivity. The model represented by CUPE1 and PLAE2 recognition that could disclose a cross-reactive carbohydrate determinants recognition, and the model represented by olive tree and plant tree reactivity that can be a genuine sensitization or possibly disclose lipid transfer protein reactivity. And we also seen reactivity to panalogen, which is linked to severity of symptoms on the basis of what kind of molecule is possibly involved in your sensitization. And this is a tentative algorithm for lipid transfer protein reactivity. If you have more than 5 molecules, monoreactivity to lipid transfer protein, you have an high risk to develop systemic reaction. If you have less than 5 molecules and multiple reactivity to more than one panalogen, you can have a lower risk, but such situation could be totally reverted in the case of possible presence of cofactors that are physical exercise, non-steroidal drugs, ingestion, and alcohol consumption. And if the question is if diagnostic algorithm in molecular allergology work or not, my response is they do work, definitely. Thank you very much.
Thank you, Enrico, for this really comprehensive review and the final answer. Are there questions coming? In between that, somebody is going to prepare. I have one question about, you have presented a lot of data coming from Italy, from your own experience, clinical and laboratory experience. How much are algorithms that are produced in one geographic area, that may be valid, as you say, in one geographic area, can be extrapolated, generalized, and used in other world areas?
Poorly, because just observing the behavior of our patients in southern Italy, in central Italy, in northern Italy, we could see total different picture of sensitization. We could found, for example, monoreactivity to lipid transfer protein in the Isles, and the presence of PR10 reactivity with very low level of PR10 reactivity in Northwest. So total different pictures.
Okay, this is the epidemiological difference in the prevalence of pattern of sensitization. My question is that if you apply a certain diagnostic algorithm, is this algorithm anyhow, independently from the area, applicable in other areas where the prevalence is different, but in principle the association of severity of certain biomarkers should
probably
be the same or is different?
Yes, probably you can apply the same algorithm, especially if you consider that there are migration of population across Europe or across the world. Therefore, you can find different situations in different parts of the countries considered. But the fact that cofactor could enhance reactivity is a good point for algorithm. The fact that multiple molecule recognition could reduce the reactivity, probably because we are not focused to just one reactivity but to multiple reactivity, could be possibly extrapolated also for other countries and other conditions.
Are there questions still? Good. If not, thank you very much for your talk.